Okay, so let's jump in. We're doing a deep dive today on a very specific piece of hardware.
Hmm.
It's the NTI E-AV-K air velocity sensor.
Yeah.
And right off the bat, our sources say it retails for $670.
Yeah, which sounds like a lot.
It does. So our mission today is to figure out, what kind of engineering justifies that price.
Well, it really comes down to reliability. And reliability in really critical environments. This isn't your average weather vane.
Right.
It's designed for mandated consistency. The specs are, well, they're impressive. A flow range of 0 to 2,000 feet per minute.
Which is what in metric?
That's about 0 to 10 meters per second.
Okay, and here's where it gets really interesting on the precision side. The general accuracy is plus or minus 60 feet per minute. But it's paired with a proportional accuracy of plus 4% of whatever value it's measuring.
And that right there is the key. That proportional accuracy, that's the insight.
Why is that so important?
It ensures that whether the airflow is super high or incredibly low, which is critical in, say, a pharmaceutical clean room.
Or a data center. Maybe.
Or a
Yeah.
high-density data center, exactly. The reading remains certifiably compliant. You pay that $670 for that certainty.
It was that calibration. So to keep that kind of, microscopic precision, this thing must be built like a tank.
Oh, absolutely. It's listed as dust resistant, for one.
But what kind of extreme environments is it actually rated for?
Well, if you look at the operating conditions, it's pretty clear this sensor is not designed for human comfort. It can handle temperatures from a frigid -4 all the way up to 140 degrees Fahrenheit.
Wow, that's minus 20 to 60 Celsius.
That's it.
So this one sensor could survive in a freezer vault or, I don't know, the attic of an industrial building in Phoenix in August.
It really could. That speaks volumes. And you combine that with a huge humidity tolerance, 5 to 95% non-condensing. It's built for resilience.
Okay, but it's not a standalone device.
No, not at all. It requires a whole support system.
Which raises an important question. Why does a sensor this sophisticated need external parts? It says here it requires the ES5 VDC converter.
It does, and it has to be powered by E2D, 5D, or 16D units.
So why?
It's because it's part of a robust, a closed-loop network. Think of that ES5 VDC converter as its translator.
The translator. Okay.
Yeah, it makes sure the very specific analog data from the sensor is properly formatted for the main NVROM-UX unit.
Which handles all the power and networking for the whole setup.
Exactly.
And that, I think, leads us to the real aha moment here, which is about scale.
Right.
The standard cable run is 1,000 feet. That's already massive, like a big factory floor.
It is. But if we connect this to the bigger picture, the system truly scales up to, like, infrastructure-level monitoring.
How so?
The compatibility with the EFSC fiber converter, that's the game changer.
What does that do?
It allows this one air velocity sensor to be extended up to 1.2 miles. That's 2 kilometers away from the main unit.
1.2 miles. Okay, so you're not just monitoring a server room at that point.
No way.
You're monitoring an entire university campus, an airport hangar, a massive utility network, all from one central spot.
And that capability, that signals very high-stakes applications, which is why all the compliance matters.
You mean the regulatory approvals?
Yep. CE, RoAS, and it's TAA compliant. That confirms it's robust enough for, say, government projects where quality assurance is absolutely mandatory.
Right, so this sensor doesn't exist in a vacuum, though. Let's talk about where the EAVK fits in the broader NTI ecosystem.
I think what's fascinating here is the sheer breadth of risks being monitored all at once.
You mean the other types of sensors?
Yeah. You have your environmental ones, like an optical dust sensor or a light intensity sensor, but then you have physical and security sensors that plug into the same hub.
Like the noise level sensor and,
Right.
wait, the EFNC1 fence vibration sensor?
Exactly.
Why would a company need to monitor airflow precision right alongside whether their perimeter fence is being disturbed?
Because the facility being monitored is likely a restricted, high-value asset.
Like a secure data center or a high containment lab.
Precisely. In that scenario, the system monitors 2 totally distinct threats: physical intrusion, the fence vibration, and environmental integrity. The airflow, the dust, the temperature.
So the EAVK isn't just measuring air, it's an integrated piece of a much larger risk management profile.
That's the perfect way to put it.
So the final takeaway here is that the EAVK is much more than just a measuring tool. It's a highly specific, very robust, and long-range component within a complex system.
A system built to deliver critical, compliant data across miles.
Exactly. So what does this all mean for you? If airflow in a regulated environment needs this level of precision over 1.2 miles, consider this final provocative thought. What essential regulated processes out there rely on continuously measuring things as different as light intensity, noise levels, or even the vibration of a fence? Something for you to chew on until the next deep dive.